Recently I stumbled upon a very cool TikTok video from a creator called Luke, where he showcased a technique that combines capacitive touch sensors with LEDs. Because I've never seen something like that before, I wanted to see if I can replicate it and take you along on my journey. All credit for this of course goes to the original creator, and I will link his video in the description below. Capacitive touch sensors work by detecting a difference in capacitance, which is the ability to store electric charge. The sensor itself works like a tiny capacitor with a copper plate that is isolated by a non-conductive layer, and your finger, or any conductive material for that matter, works as the second plate. When your finger comes close, the electric field around the copper plate changes, which can be detected as an input signal. Because the sensor needs a non-conductive layer to work, we can even detect touch through thin plastic. Interestingly, the shape of the copper plate doesn't matter much. Whether it's round, square, or even has a hole in it, the sensor still works. That's because the sensing relies on the electric field that the copper plate generates, which is independent from the plate's shape. What this means is that we can drill a hole in our sensor and hide an LED behind it, while also covering everything up with a thin layer of plastic using 3D printing. For this project I will be using the TTP223B capacitive touch module. They are quite cheap and I got 10 of them for around €7 on Amazon. The sensor can be used between 2 and 5.5 volts and has a momentary active high output, meaning as long as it detects proximity, it provides a high output. We can easily test this without a microcontroller, just using a breadboard, an LED and a couple of jumper wires together with a power supply. Now let's make this a bit more interesting by introducing an addressable LED. First, I desolder the pre-installed pins from the breakout board. Then I drill a hole in the center of the sensor using the simple 3D printed jig that I made to help me align my drill with the middle of the plate. Then I solder 3 jumper wires to my addressable LED and strip the insulation from the power and ground cable for a bit more, so I can use them to also supply power to the capacitive touch sensor. Lastly, I connect the ground and power wire to the respective pins of the capacitive touch sensor, add the data wire for the sensor and secure the LED in place using some hot glue. I know this method is a bit messy, but it's the best I found for now. Now we can construct the housing for our self-made breakout board using Fusion 360. To give the light a shape, we can also add a small icon into our print. This design is meant to enclose the sensor and the LED while printing, but for other projects we can of course also leave the sensor as it is. With the hardware out of the way, we can write a short script to read the data of the capacitive sensor and turn on the LED whenever it senses a touch. To demonstrate this method, I've built a simple Simon Says game using 3 of these sensors, a Raspberry Pi Pico and a small LCD screen in a 3D printed housing. However, it can of course be applied in various other settings as well, and I think it's a really cool trick to add to your arsenal. I hope this video was helpful to you. The code and the CAD files for the drilling jig as well as the custom sensor housing are as always available in the GitHub repository that you can find in the description below. If you have questions or want to show off your own project you built using this video, feel free to join my Discord community server, which is also linked below. See you in the next one.